Hello everyone. These are the topics that I have gotten for my seminar. As you can see, I have listed them on the screen. So we can go through them one by one. So the first one is process creation. So before we move on to process creation, let's briefly explain what a process is. So a process is an instance of a program running, and its life cycle includes various stages such as creation, execution and deletion. So the process creation is handled by the operating system. So what operating system does is it allocates necessary resources that each process requires, and it also assigns a unique identifier that which we call PID for each processes. And each process has its own process control block, the PCB, and an address space. Also, the operating system uses process states to manage processes. So the process states are new, ready, running, waiting, and terminated. Now let's take a look at the steps in process creation. So these are the steps in process creation. So the first one is assigning PID. So we have discussed PID is the unique process identifier. So the operating system assigns this unique PID to the new process, and it is also inserted into the primary process table as a new entry. After this, we move on to the memory allocation. So for this process, a certain amount of memory is allocated for the process elements such as program, data, and stack, and including space for its process control block. After allocating the memory, the next step is to initialize PCB. So the PCB or the process control block is initialized with values such as the PID, which is the unique process identifier, and parent PID, which is identifier of the parent process. And then there are stack pointer, program counter, and process state. After this step, we move on to the linking to schedule queue. So this process, the new process, is linked to the scheduling queue, and here the state will be changed from new to ready. After this step, we can create additional data structures like log files or accounting files that are related to the process activities. So here we can note that usually we create a process from a parent process. So we have a parent process and then there is a child process. So these are the steps involved in creating a process. So let's move on to the next topic, that is page replacement. Page replacement refers to the process in operating systems where a page in main memory is replaced by a page from secondary memory when a page fault occurs. Take a look at the figure given. Here you can see in the physical memory there is a faulty page, which is the victim. So step 1 is we swap out the victim page, and in the page table we change the state to invalid, and then we reset the page table for a new page, and then a new page is swapped in from the secondary memory. So this is how page replacement works. So why we do this is to reduce page faults, to improve CPU utilization, and it also results in better throughput and response time. Now there are a few algorithms that we follow in page replacement. So let's take a look at some of those algorithms. So these are the types of page replacement algorithms. I have listed out 3 algorithms. The first one is FIFO algorithm, or the first in first out. So in this algorithm, the oldest loaded page is removed first, and one advantage of this algorithm is it is easy to implement using a queue. The second algorithm is optimal algorithm. In this algorithm, the page that will not be used for the longest time in future is replaced. And one advantage of this algorithm is that it gives minimum possible page faults. The next is the LRU algorithm, which stands for least recently used. So in this, the page that was not used for the longest time in the past is replaced. So this algorithm is closer to optimal than FIFO. Now note that these 3 are not the only algorithms in page replacement. These are just the most commonly used algorithms. The other algorithms are, one is LFU, which stands for least frequently used. Another one is MRU, which is most recently used. And then there are many more algorithms. Moving on, our next topic is allocation of frames. So frame allocation in operating systems refer to the method of distributing physical memory frames among various processes to optimize performance and manage memory efficiently. So in allocation of frames, there are two algorithms. These are equal allocation and proportional allocation. Also note that the number of frames allocated to a process can also dynamically change depending on whether you have used global replacement or local replacement for replacing pages in case of a page fault. So in the previous topic we have discussed page replacement. So depending on whether we use global replacement or local replacement, the number of frames allocated can change. So this we will discuss after the two algorithms. So now let's move to the two algorithms. So the first type of frame allocation algorithm is equal allocation. In this, the frames are allocated equally to all processes. So consider a system with X frames and Y processes. And here each process gets equal number of frames, that is X by Y. Let's take a look at an example. If the system has 48 frames and 9 processes, here each process will get 5 frames and the remaining 3 frames will be used as a free frame buffer pool. Now this type of allocation has a disadvantage, that is in systems with processes of varying sizes, it does not make much sense to give each process equal frames. That is, if there is a small process, it does not need an allocation of large number of frames. This will lead to wastage of allocated frames that are unused. The next type of allocation is proportional allocation. In this, the frames are allocated to each process according to its process size. So if there is a process Pi of size Si, the number of allocated frames is given by Ai, which is Si divided by capital letter S into M. Here S is the sum of the sizes of all processes and M is the number of frames in the system. Let's take a look at an example. If there is a system with 62 frames and there are two processes, one of 10 KB and the other of 127 KB, the first using the equation that was mentioned, will get that first process will be allocated 4 frames, the other process will be allocated 57 frames. So one advantage of this type of allocation is that all the processes share the available frames according to their needs rather than equally. Moving on, let's take a look at what differences are there in global replacement versus local replacement. So in local replacement, when a process needs a page which is not in the memory, it can bring in the new page and allocate it a frame from its own set of allocated frames only. So this is local replacement, and its advantage is that the page is in memory for a particular process and the page fault ratio is affected by the paging behavior of that process only, since we are only allocating the frame from its own set of allocated frames. So here there is a disadvantage as well, that is a lower priority process may hinder a higher priority process. So this is the local replacement. In the case of global replacement, when a process needs a page which is not in the memory, it can bring in the new page and allocate it a frame from the set of all frames, even if that frame is currently allocated to some other process. So this is global replacement. So its advantage is that it does not hinder the performance of processes and hence results in greater system throughput, unlike local replacement. And its disadvantage is that the page fault ratio of a process cannot be solely controlled by the process itself, because we are allocating it a frame from the set of all frames. So the pages in the memory for a process depends on the paging behavior of other processes as well. So this is global replacement. Now let's move on to our next and last topic, that is thrashing. So what is thrashing? Thrashing occurs when the operating system spends more time swapping pages between main memory and disk than executing processes. Now this leads to excessive page faults and a significant drop in CPU utilization. So why this occurs? Take a look at the figure given. Here you can see a graph between degree of multiprogramming and CPU utilization. So at one point it is increasing, and when it reaches a certain point, it becomes too much and then thrashing occurs. So in the cycle, when too many processes are loaded into the memory, that means it has reached a point of high degree of multiprogramming, and this leads to lack of frames. That is, each process gets fewer frames than needed, and then this leads to frequent replacements, which then leads to increase in page faults. So this repeated cycle of low CPU utilization, which leads to more processes, which leads to more page faults, is called thrashing. So this is thrashing, and as you can see, obviously thrashing is not good and we need to handle it. So there are some techniques to handle this thrashing. So let's discuss techniques to handle thrashing. So there are two techniques in handling thrashing. The first one is working set model. In working set model, for each process, the operating system keeps track of the pages it used in the last delta references. So this delta references is a time window, and this set is called the working set. So if the process has at least these pages in the memory, page faults stay low. That is, if the total working set sizes of all process is more than available frames, the operating system suspends some processes or swaps them out completely. So the remaining process get more frames, and hence the thrashing can be reduced. This is one way to handle thrashing. And here we need to note that the accuracy of this technique depends on the delta value. So if the delta value is too large, the working sets may overlap, and if the delta value is too small, the locality may not be fully captured. The next technique to handle thrashing is page fault frequency. So page fault frequency, or PFF, is a technique to control thrashing by directly monitoring the page fault rate of processes. So here's how it works. So we'll define an upper limit and lower limit for acceptable page fault rate, and if this page fault rate is greater than the upper limit, we give more frames to the processes. And if this page fault rate is lesser than the lower limit, we take away some of the frames. And if no frames are available, suspend some processes and reallocate frames. So this is another way to handle thrashing. We can use either of these techniques to handle thrashing. Now let's move on. Here is an overview of all the topics that I have discussed. So the first one is process creation. Here we have discussed how the operating system handles processes, and also we discussed the steps in process creation. The second topic was page replacement, and in this we discussed what a page replacement is, how it works, and different algorithms in page replacement. The next one is allocation of frames, and we discussed what and how frames are allocated, and we also discussed equal and proportional allocation and global versus local replacement allocations. The last topic that we just discussed was thrashing. So we have seen what thrashing is, and we have seen techniques to control thrashing. So that is pretty much it. Thank you.